Today we are going to learn about optimizing data pipelines for LLM training. We'll delve into designing efficient data flow for LLMs, focusing on reducing training time and resource consumption. Welcome to our session on optimizing data pipelines for LLM training. In this video, we'll explore how crucial data pipelines are in managing and optimizing the flow of data for training large language models, LLMs. By optimizing these pipelines, we can significantly reduce training times and resource consumption, making the process more efficient and scalable. We'll cover various aspects, including data preprocessing, augmentation, storage management, and more, each contributing to a streamlined and effective data pipeline.
Data preprocessing is a vital step in preparing datasets for LLM training. It involves cleaning, transforming, and organizing raw data into a usable format. The first step is defining the preprocessing requirements based on the specific needs of your LLM architecture. This can include tasks such as data cleaning, where you remove duplicates and correct errors, and data normalization, which involves scaling the data to a range that's suitable for training. Handling missing data is another crucial aspect, as it can significantly impact model performance if not addressed properly. Tools like Pandas for Python can be invaluable for these tasks, providing methods for data cleaning and transformation. Ensuring high data quality is essential, as poor quality data can lead to inefficient training and inaccurate model predictions. Data augmentation involves creating variations of the existing dataset to improve the model's ability to generalize. This can be particularly beneficial for LLM training, as it increases the diversity of the training data without the need for additional data collection. Common techniques include synonym replacement, random insertion, and back translation. These methods help in creating different variations of the text data, thereby enhancing the robustness of the model. Balancing dataset diversity is crucial here. Too much augmentation can introduce noise, while too little might not provide enough variation. Tools like the NumPy library in Python can assist in implementing these techniques effectively. By using data augmentation, you can significantly improve the model's ability to handle a variety of real-world inputs. Efficient data storage and access management are critical for optimizing data pipelines. Choosing the right storage solution can greatly impact the speed and cost of your data operations. Options range from cloud storage services like AWS S3, which offer scalability, to local storage for faster access times. Optimizing data retrieval speeds is another key aspect, as it directly influences the training throughput. This could involve indexing strategies or using in-memory databases for frequently accessed data. Storage costs should also be considered, balancing between speed and cost-effectiveness. Tools like Apache Hadoop or Google BigQuery can help manage large datasets efficiently, providing the necessary infrastructure to store and retrieve data at scale. Parallel processing is an approach that divides tasks into smaller, independent chunks that can be processed simultaneously, significantly speeding up data pipelines. For LLM training, this means faster data preprocessing, augmentation, and loading times, which in turn reduces the overall training time. Implementation strategies might include using multi-threading or multiprocessing within your data pipeline. Python's multiprocessing module or distributed computing frameworks like Apache Spark are commonly used tools for achieving parallelism. By breaking down tasks and processing them concurrently, you can make the data pipeline more efficient and reduce bottlenecks. Case studies have shown that implementing parallel processing can lead to improvements in training speed by several magnitudes, especially for large datasets. In the era of data-driven solutions, ensuring data security and privacy during LLM training is paramount. This involves implementing encryption techniques to protect data both at rest and in transit. Understanding data privacy regulations, such as GDPR or CCPA, is crucial to ensure compliance and to avoid legal ramifications. Best practices include anonymizing sensitive data, using secure access protocols, and regularly auditing data access logs. Tools like TensorFlow Privacy or PySift can aid in maintaining privacy and security within your data pipelines. By integrating these practices, you not only protect sensitive information but also build trust with users and stakeholders. Handling large datasets efficiently often requires the use of distributed computing, where computational tasks are spread across multiple nodes. This approach allows for processing massive amounts of data simultaneously, which is essential for large language model training. Frameworks like Apache Hadoop and Apache Spark provide the infrastructure needed to implement distributed computing, offering tools to manage data distribution, fault tolerance, and scalability. While distributed computing presents challenges, such as data synchronization and network latency, solutions like data partitioning and efficient node communication can help mitigate these issues. Real-world applications of distributed computing include processing large-scale datasets in industries like finance, healthcare, and e-commerce, demonstrating its effectiveness in handling big data challenges. Monitoring and analyzing the performance of your data pipeline is crucial for ensuring its efficiency and effectiveness. Key metrics to track include data throughput, processing time, error rates, and resource utilization. By keeping an eye on these metrics, you can identify bottlenecks and areas for improvement. Tools like Apache Kafka, Prometheus, and Grafana can assist in collecting and visualizing performance data, providing insights that drive continuous improvement. Implementing a robust monitoring strategy allows you to adapt your data pipeline to changing demands and ensure it remains optimized over time. Case studies have shown that effective performance monitoring can lead to significant improvements in pipeline efficiency and resource utilization. Large language models come in various architectures, each with unique requirements and characteristics. Adapting your data pipeline to accommodate these differences is essential for optimizing performance. Understanding the specific needs of architectures like GPT, BERT, or transformer models allows you to tailor your pipeline accordingly. Flexibility and scalability are key. Your pipeline should be able to adapt to different model sizes and configurations. Tools like TensorFlow and PyTorch provide functionalities to customize data pipelines for specific model architectures. By implementing architecture-specific optimizations, you can ensure that your data pipeline is not only efficient but also capable of supporting a wide range of LLM architectures.
In conclusion, optimizing data pipelines for LLM training is a multifaceted process that involves careful consideration of preprocessing requirements, data augmentation, storage management, and more. Efficient pipelines are crucial for reducing training time and resource consumption, allowing for scalable and effective LLM training. As technology evolves, staying updated with the latest trends and continuously adapting your strategies is vital. We encourage you to implement the strategies discussed in this video to enhance your data pipeline efficiency and contribute to successful LLM training endeavors.